Hello and good evening, students. How are you? I hope you are doing good and everything is fine with you. So, here we are with our lecture number 4 on calorimetry and thermal expansion. And I hope this could be the last lecture of this series of thermal physics. Okay. So, as I was able to see you because you have opened the camera, there are only two students in the class. So, where are the other students? They will come or not? Okay. Good evening, JNV. It's 9 लिखे थे. So please do write your name, na? Because that's JNV 9. So okay, got it. So my purpose is not to bore you. Okay. Hello, Kashma. Good evening. Shama, I think. Okay. So sorry for the mispronunciation of your name. Okay. Now I don't want you to uh, feel bored in this subject because this is very interesting subject, I think, and I love the most. I have did my engineering, but if you ask me that what is your favorite subject, that I would like to say that it is physics, and it just not my favorite subject. I love this subject. During my engineering, when I was doing my engineering, after the class breaks, I also get the breaks in during the classes. So I used to study physics, textbook like NCRT and other textbooks, Holiday, Resnick, and other various competitive exams book, physics book. So it's just the passion of me that I came across this teaching profession instead of, although I have offers in my hand to join the engineering companies, the fundamentals. You must have heard about the Maruti Suzuki, है ना? So I have left the job in that company just to start my career in teaching. Okay, so I strongly believe that if the subject bore you, that you can't learn that subject. Okay, so you need to be interesting about what is going on. Okay, and that this interesting part what I'm telling you is came when you study. Okay, so if you do not study a single word that I have told you in the previous class, so this class means nothing, because even in a chapter there is a succession of the concept. Okay. And also physics is nothing but the relation of human body with this nature. Okay. How the things are related in nature, study of that phenomena is termed as physics. Okay, so be observable, observe the things that is around you, how they works, what the physical phenomena is acting in them, what physical law is acting in that. Okay, how we can improve the things. This all enhance your curiosity. Okay, so whatever the textbook that you are reading, I guess you read, because most of the students do not read the textbook. They will only depends on what the teacher says, notes. Okay. I would not recommend you that. I would recommend you that study the notes that is given by your class teacher or by me also, but make a space for this textbook and start from NCRT. Like today we are going to mostly our focusing on radiation. Okay, so after the class has been over for today, read this chapter, radiation, in NCRT, or the textbook that you have. I think you are studying from NCRT, na? Yes or no? Okay, got it. So this is the fact. Keep updating yourself with the help of this textbook. Okay, so please consider at least one of the textbook that you can study. Okay, so as we have discussed that in heat transfer, mostly the topic that we have covered in previous classes, conduction and convection. So we are going to revise that, conduction and convection. Then we are focusing on the radiation and Newton laws, or laws of cooling. And also we will see a very interesting phenomena, the growth in the ice pond. Okay. Generally, we will see in the winter time what will happen. The lakes got frozen. Okay. So how thick the layer of this ice would form in how much time, that we will going to discuss today along with radiation. Okay. So tight your seat belt and let's just get started with it. Now, in conduction, what we have seen. Okay. So heat transfer, we have three parts: conduction, convection, and radiation. Okay, this phenomena we have seen. What is heat transfer? So heat transfer is nothing but the transfer of heat from hotter temperature source to lower temperature. So it is heat transfer from hot body to cold body. Okay. Now, so how many ways the heat can be transferred? So we have three ways: conduction, convection, and radiation. Now, if I talk about the conduction, what is conduction? So it is the mode of heat transfer when it is the mode of heat transfer by direct contact. Okay. So when bodies are in direct contact, they will transfer heat from one body to another body. And how it will be possible? It is possible because of the temperature difference. Look, there is a simple analogy. Huh? If this is a high place, let's say this type of place I have made, and here I have put a vessel of filled with water. Okay. Now, if I drop the water at this surface here, what will happen? The water will naturally come down. How it is possible? It is possible because at this place, the height is, let's say, h, and at this place, the height is low, or you can say 0. So due to the difference in height, water will flow, or water current will flow. You can take the example of rivers that are flowing. So river flow from high place to low place. high altitude to low altitude. Why? Because there is a difference in height. So they will travel to from higher places to lower places. That is why we place the water tank at the very top of any surface. Okay, not in the bottom. So this flow of water is nothing but the water current. Water current. So this development of this current is happen only because of the difference of some physical quantity. So here the difference is of height. Okay? And due to height, the pressure would vary. Got it? So that is why this water is flowing down. Okay? Now, if I talk about the electric current, this is the, let's say, resistance R you have studied in your 10th class. And there's a potential difference V here. The current will be flow in this circuit is I. So we can say that V is equals to IR. Now this current flow because of this potential difference. This plate, the bigger plate is of higher positive potential, and this plate is of negative potential. Okay. So current always flow from positive to negative, higher potential to lower potential. Got it? Now, so this current is the electric current. In the previous example, that current is the water current. Now, if I talk about heat or heat current, if here is the I have use a flame, and this is made up of metal. So what will happen if I place this rod, one end of this rod in this flame? What will happen? The temperature of this end will rise up, and this end is at somehow lesser temperature. So what will happen? We have a difference here, difference of temperature. Now, due to this difference, there will be a development of heat current from higher temperature to lower temperature. Got it? So this is also a type of current named as heat current. So heat current is only possible of because this temperature difference. So we can say that the force, the driving force of this heat current is temperature difference. The driving force of this water current is difference of height or difference of pressure. The driving force of this electric current is potential difference. Okay, got it? Now, so now you can understand. I think you have understood it. What is heat current actually and how it is developing? So it developed because of the difference in temperature. Now we know that when two body come closer of different temperature, they will exchange the heat or they will exchange their temperature. We can say that because of the definition of thermal equilibrium. So how they are maintaining the, how they are achieving the thermal equilibrium? Suppose we have a body here which is connected by a metal thing. This is metal rod. This is at temperature TA. This is at temperature TB. TA is greater than TB. So we can say that there will be after some time there will be a development of thermal equilibrium in that. So how it is possible? It is possible because heat is flowing from higher temperature to lower temperature. Okay. So this heat flow, or you can say heat transfer, is possible because of the direct contact. It is the direct contact heat transfer. So that mode of heat transfer is termed as conduction. Okay. You can say it direct contact. Okay. Direct contact. Got it? Now, the equation of heat flow here, equation of heat flow or heat current is given by H is equals to dq by dt equals to K A dt. Dt is the temperature difference divided by dx. And this would be in negative sign. Why negative? Because heat always flow from higher temperature to lower temperature. Got it? So this difference dt would be written as T final minus T initial. So T final is lower. T initial is greater. So this value come out to be negative. So that is why to make this term positive, we have apply a negative sign. This you would have remembered. Got it? Now, this is also termed as the Fourier law of heat conduction. Just a second. Fourier's law of heat conduction. Okay. जहां पे भी प्रॉब्लम आए समझने में तो यू कैन raise your hand or send me a thumbs up and put the message in the chat box. Got it? So this equation you will remember. Ka dt upon dx. Got it? Now, what is steady state heat conduction? So steady state heat conduction is nothing but initially what will happen. These are the blocks. I have explained you in the previous lecture. So this is at temperature Ta, this is at temperature Tb, and we can say that Ta is greater than Tb. Now what will happen initially? Initially, okay. So initially, due to temperature difference, due to temperature difference, the rate of heat flow is unsteady because because temperature T, this is temperature, is changing with time. Okay, initially what will happen? It is changing with time. But after these bodies are in thermal equilibrium, these bodies are in thermal equilibrium, so temperature of the body will same. So Ta equals to Tb. So you can say that heat inflow is equals to heat outflow for a cross section, for a specific cross section area. Okay, if I consider this as a specific area, so when the temperature difference is same, So you can say that there is no heat transfer, or you can say that whatever the heat is coming, same heat is going. Got it? So then you can say the temperature is same, temperature difference is same. So this observation is termed out as steady state heat conduction. Got it? Which you can give as dq by dt is equals to, which is equals to h ka dt by dx. This one. Then what you can say, this h here is equals to ka dt by dx. So h dx is equals to ka dt. If you integrate it from t1 to t2, and this 0 to L. So this will become HL equals to Ka T2 minus T1. Now this T2 is here equals to T1 minus HL upon Ka. This is the steady state heat conduction, which is the linear relationship with H. Okay. The slope will be like this. Okay. This is delta T with respect to length. This is the steady state heat conduction. Clear? Now, thermal conductivity and thermal resistance. So this K in the heat equation, heat current equation, which is H is equals to dq by dt, Ka upon Ka into dt. Here dt is the difference of temperature by dx. So here the K is the thermal conductivity. Okay, depends on nature of substance or material. But if you take it for average value, so this H is nothing but delta Q by delta T for a relevant time interval, not a very small. This time interval is sufficient that you can observe a measurable amount of heat transfer. So this will become Ka delta T into L for entire length. Okay. So if you compare it with Ohm's law, which is V is equals to IR, or you can say V is equals to Ri. So V is the driving force here. I is the current, electric current, and R is the resistance. कौन सा resistance? Electric resistance. Same way में we can compare it with H is equals to Ka upon L into delta T. Now I have told you that heat is transferred because of the temperature difference. So this is our driving force. Okay. So this could be the heat current. This is the heat current. Now what is remaining? So you can say that delta T is equals to L over Ka into H. Now this delta T replaces V. This replaces R, not 1 by R, it is directly R, and this H is I. So from here you can say that thermal resistance is L over AA. Got it? Now, if I just change the screen here, so thermal resistance in series, what is the value? So RT, R1 plus R2, or I will write here R equivalent, R1 plus R2 plus R3. And what is the value of heat current? So Q is Ka delta T by L. This will be the same. For example, if these are the two blocks we have, from where we have to transfer the heat, and we have attached number of metallic rod to them. Okay, this is of a length L1, L2, L3, L4, and so on. Okay, the area of cross section भी मैं different लेके चल रहा हूँ, A1, A2, हालांकि it seems to be same but it is different, A3, A4 and all. And thermal conductivity is also K1, K2, K3 and all. So we can say that temperature here is, let's say, T1, and here the final temperature is T2. Got it? So what is the temperature of this junction? We will assume it at T. So we can say that R equivalent L1 upon K1 A1, L2 upon K2 A2 plus and so on. This is the resistance. What about heat current? Heat current is H, which is given by, it is not Q, it is H. Okay, it is given by Ka delta T by delta or the length. Now you have to be careful. This should be equals to the temperature difference, because in series the heat current will be same. So we can say that this is equals to K1 A1. And what is the temperature difference between this? Let me change the color. What is the temperature difference at this end and this end? It is T1 to T. We can say that T minus T1 divided by, and what is the length? It is L1. This should be equals to K2A2. Again, the temperature of this end and this end. So it is T, and here we have considered T, let's say T dash. So it is T dash minus T. And what is the length? Length is L2. So this is how you can write the heat current. So if the temperature is unknown of this point, so you can easily calculate. Got it? So please note it down. So I will write it for the parallel also. Or I will write it here. No problem. For parallel, 1 upon R equivalent is K1 A1 upon L1, K2 A2 upon L2, K3 L3 over L3, K3 A3 over L3 up to and so on. And this is nothing but 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus and so on. Okay. And the value of heat current would be different. ठीक है, for different length, and how they are connected I will show you. So when you note it down, just give me a thumbs up. Okay, then I will move on. I think you have noted down, huh? Okay, got it, got it. Now, for parallel connection के लिए, what will be the figure? For parallel connection, these are the two blocks or two systems for which the heat transfer is taking place. Let me make it a big one. So temperature here is T1. The temperature of this source is T2. So there are number of rod connected to it like this. So these are the parallel connection. Okay, got it? So length will be same for all of them. Although the area of cross section and thermal conductivity can vary. So heat current you can write H is equals to K1 A1 what? T1 minus T2. Okay. And this is H1 upon L. H2 will be K2 A2 T1 minus T2 divided by L. Due to the difference of this quantity, these are difference. Although we can say that net heat transfer is nothing but H1 plus H2 plus H3. Okay. So you can note it down the thermal conductivities of different bodies. These are the metals. Just a second. So these are the metals. These are non-metals and these are the gases. For gas, the thermal conductivity is very low. Now, what is convection? Convection is the transfer of mode of heat transfer between solid surface and fluid surface and fluid in motion. Okay, so that value of heat transfer, that mode of heat transfer is termed as convection, in which itself mass is transferring the heat. Okay, so if this is the solid surface we have and the fluid is flowing through it, so we can say that after some time this solid surface will cool down. So how it is possible? So it will possible because this solid surface transfer heat by conduction to the adjacent layer of the fluid, but above that layer all the heat that is transferred to this another layers of fluid will be happen because of the convection. Okay, so I have done a detailed discussion on that in the previous lecture. So these are of two types. This is of two type. First one is natural convection and second one is the forced convection. Forced convection में water heater, oh sorry, room heater you can take the place, room heater, specifically blower. Okay, so this is the best example of forced convection. So this blower forcing the cold air to be warm. Okay, but by forcefully. So it is extracting heat. Oh, sorry, it is making the cold air warmer by extracting the cold air from the atmosphere forcefully with the help of the fan. So this is forced convection. Okay. Now we will talk about the growth of ice in pond. So let us consider till now. If anyone have any kind of doubt, they can ask. So this is water, and let's say this is the thickness x thickness tak we have developed the ice. This is ice. Got it? Now we will say that in dt time. So growth of ice, how the ice will develop when temperature of water go below 0 degree Celsius, it start freezing or conversion into ice. Got it? So let us consider the growth of ice is in dt time. So sorry. So sorry. In dt time is dx. So this dx thickness has been developed, this new one. This dx thickness of the ice has been developed in dt time with change of temperature d capital T. Okay. So how this ice is forming? So here we have this water. This is at higher temperature than ice. So this will make a direct contact with this ice. So what will happen? It will transfer heat in this way from higher temperature to lower temperature. And the mode of heat transfer here is conduction specifically. Conduction. So what is happening? The phase of the water is changing into ice. Okay. So that heat, this water, this warm water is transferring to ice is to change the phase. So we know that Q is equals to ml for phase change, because here the phase is changing. Temperature is 0 degree Celsius. This ice is forming at 0 degree Celsius. Okay. But the heat is constantly transferring into it. So where this heat is going? This heat is going to change the phase of this water into ice. So this heat we can say is Q is equals to ml. Now what we will do? We will differentiate this because we want to relate it with time. So dq by dt is equals to d by dt of m into L. Now this will become L is constant, latent heat of fusion, into dm by dt. Now, mass M, you can write it as rho into area into what? Rho into volume, density into volume. So volume, we are interested only this part, dx thickness. So let the surface area is A and thickness here is dx. So this strip is of like this. Dx is the thickness, surface area is A. So what is the volume of this cuboid? Volume will be dv, you can say A dx. So mass of this system will become m is equals to rho into dv, and dv is equals to A dx. So we can say that here it is rho L A dx by dt. This is equation number 1. Okay. We also know that we also know that because here the rate of heat transfer is conduction, the mode of heat transfer. So we also know that this dq by dt is also given by what? K A dt by dx. Now this is equation 2. On equating equation 1, equation 2. Now this will become Ka dt by dx is equals to rho into L into A dx by dt. Got it? So this A and A you can cancel out here. So what you will have? You will have K into dt by dx is equals to rho L dx by dt. Okay. Now note it down from here. When you note it down, give me a thumbs up. Okay, that we have noted down. Okay. So I think we have to make another PPT here. So we are here that Q we know this rate of heat transfer dq by dt is also equals to what? K A dt by dx. Now this conduction is possible. This conduction is happening because of this frozen ice which has a thickness of x. The conduction is happening between this frozen ice, this ice, and this water. So rate of heat conduction, I will say this will equals to K of ice, conductivity, thermal conductivity of ice, area of the surface, temperature difference is T minus 0. Let's say this is at temperature T and initial temperature was 0. So it will be taken as T divided by the thickness is x. Now we have to equate it with this K ice, or you can make it in that expression also that we have equated. So K ice into A T upon x is equals to what? We have rho L A, sorry, L here is the latent heat of fusion, not the length. L into rho A dx by dt. Now A and A will cancel out here. So we can say that this x dx is equals to K of ice into T upon L rho. So if you integrate it for 0 to x and in time 0 to t, so you will have x square by 2 k of ice into t divided by L rho into t, small t. Now, what is the time? So time here is, if I get to know the value of small time t, which is equals to rho into L divided by k of ice into temperature T multiply with x square into 2. This. So this is the time T to grow the ice upon the water up to thickness x. Okay. So here you can say that T here is directly proportional to x square. So the growth of ice will be a parabolic in nature. Okay. So if you plot time versus thickness, we can do that. So it will be a parabola. Now note it down and give me a thumbs up when you note it down, because we have to finish this chapter today. Okay. Now the only thing that we have remaining is radiation. Okay. This one and then that one. After that we have radiation. So what is radiation? We have rate of heat transfer by conduction, by convection this way. But what is radiation? Radiation is the fastest mode of heat transfer in which heat transfer takes place because in the absence of any medium. Okay, and it does not require any contact. So that mode of heat transfer is termed as the radiation. So for that we can transfer heat. Just a second. In the radiation we can transfer heat without heating the intervening medium. Okay, and without actual movement of source or receiver, as we have received the sunlight, which is also a radiation. So our earth does not have to move to receive that radiation, or sun does not have to move to give this radiation to earth. Okay, and also in between them we know there is a vacuum, so it does not need to be hot. The vacuum will hotten initially, then the radiation will transfer. No, this is not the fact here. In radiation we do not require any medium for heat transfer. In the conduction we have attached a metallic rod to transfer heat from this part to this part. Okay, in convection we need a fluid layers and a solid surface, but in radiation we do not require such that anything. So this will be the transferring of heat with the electromagnetic wave, in the form of electromagnetic wave, because we know that the sun rays that is coming from sun to earth is UV rays basically, and UV rays lies in the category of electromagnetic wave. Okay, so the rate of the mode of heat transfer in which heat is transferred with the help of this electromagnetic wave is called as radiation. So that is why, because electromagnetic wave are the fastest wave that we have. So this mode of heat transfer is the fastest mode of heat transfer. So this one, so whatever the energy that we get is called as the radiant energy. This is the variation of electric and magnetic field. Okay, just remember this. Electric field and magnetic field are perpendicular to each other in this variation. Okay, we know that all the bodies emit radiant energy when the temperature of that particular body will rise up. And that particular radiation is called as the thermal radiation. As you hotten the metallic rod, this one, so this luminosity is because of the thermal radiation. Same in the case of electric bulb. So inside it we have tungsten. When we provide the electric current to it, there will be a enormous amount of heat loss in this because of the resistance of tungsten. And because of that heat loss, the temperature of the tungsten wire will get risen up. So it will emit radiation in the form of light. This is the thermal radiation that we have. Okay. Now, it is not obvious that if a body is receiving 100 watt of energy or watt of power, it will absorb all that. No. Ideally, practically, a body, some of the part it absorbs, some of the part it will reflect. Okay. And some of the part it will transmit. So whatever the heat that we got from sun, it partly absorbed by the earth and partly reflected. So if on a surface I have incident Q amount of heat, or we can say that this Q amount is radiant energy, which is coming on this surface. Now some of the part of it, let's say Q1 is reflected, some of the part is transmitted, some of the part is absorbed within it. So this absorbed part is Q2, transmitted part is Q3. So we define three terms here, which is Q1 by Q, energy absorbed, sorry, energy reflected per unit radiant energy is defined as A, sorry, small r. Q2 by Q, the energy absorbed per unit energy falling onto it, it will termed as A. Q3 by Q is termed as small t. This R here is nothing but reflectance, and it will depends on the nature of body and the nature of surface. Reflectance of surface, absorptance of surface, and T is the transmittance of the surface. And we all know that Q1 plus Q2 plus Q3 will be equals to Q because of the conservation of energy. And from that we can reduce that R plus A plus T is equals to. Now, what is that body called which absorb all the radiation? Okay, we know that practically a body, some of the radiation it will absorb, some of the radiation it will reflect. Yes, any problem? Yeah, definitely. That body is termed as the black body. Okay, so whatever the color that you will see in your daily life, whatever the color of a body, if a red hot filament, if you will see, so that color red hot is come because of the radiation that it reflected. Okay, so we know that the color of an opaque body depends on the wavelength of radiation reflected by it. Okay, now if a body is not reflecting such a any wavelength, so what color do we see generally? It will seen as a black. Okay, so black body, a perfect black body is one that absorb radiation of all wavelengths incident on it, and its absorption is unity, and it neither transmits or not reflect any radiation. But when a black body heaten up, but when a black body heaten up, it will radiate all the possible wavelength that it will have. Okay, so that is also the property of a black body. Okay, and it is not obvious, and it is not a rule that a black body should be black. Our sun is also a black body because it is emitting all the possible wavelength it will have. That is also a characteristic of black body. Got it? So that is the reason why we wear clothes, uh, colorful clothes in summer, so that they can absorb light of this particular wavelength, but we should wear black clothes in winter because it will absorb all the type of radiation. So whatever the amount of heat you are getting, it will trap into your body. Okay, and it will neither transmit it, neither reflect it. Now, what is a black body radiation? So thermal radiation radiate by the black body is called as the thermal black body radiation. So we know that black body radiate all the possible wavelength. Okay. So the thermal radiation at any temperature has a continuous spectrum from a small to the long wavelength because it has the possibility to emit all the possible wavelength, either it is small or high. But it will be maximum for a particular value of wavelength at a particular temperature. If you increase the temperature, this value of energy will increase and this wavelength on which we are getting this maximum energy will increase. So if you will see in this video, as the temperature rises for light bulb, this peak is here for this value of what? Wavelength. But when we shift it to the further higher values, you can see here the wavelength, this peak is shifting in this direction, in left direction, in this direction, from red to blue. And why it is so? Because as you increase the amount of energy, it will shift itself to the shorter wavelength. Shorter wavelength means higher energy. Okay. And this is nothing but the Wien's displacement law that we will discuss in this. So increase in the temperature, decrease the wavelength. This is nothing but the Wien's displacement law. Lambda m into T is equals to P. This lambda m is nothing but the wavelength at which we are getting the maximum value of radiant energy. This one. Okay, so as the temperature move higher, the peak will shift in this way. Here we have peak here. At this value, we have peak here. At another value, the peak will shift in this way. Okay. This one. Got it? So that is why if you increase the temperature of a body, firstly it will become reddish yellow, then finally it will become red, then yellow, and then finally it will become white hot. And if you further increase the temperature, it will become bluish. Okay. So if anyone asks you that which star has the higher temperature, so blue star has the higher temperature because blue has the shorter wavelength. Now, what is Newton's law of cooling? I think it will get only 1 minute. So will I discuss it now or I will let it know you in the next class? It will hardly take 3 to 4 minutes. Newton's law of cooling and Stephen Boltzmann law. Okay, so one thing we can do, yeah, we can discuss it, Newton's law of cooling and Stephen Boltzmann law in the weekend class. Okay, the question discussion session that we have this weekend, we will discuss this and then we start the question discussion on KTG and thermodynamics, the remaining part of that. Got it? So till now, if you have any kind of problem, any issue, any doubt, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive. It's a wonderful session with you guys. Thank you so much.